friends, in this video we will study about the logical instructions available in 8051 microcontroller. So let us start with our topic. In 8051 microcontroller, there are various instructions, and these instructions are divided into different categories depending upon the type of operation performed by them. Like if it performs data transfer operation, they comes under the category of data transfer instructions. Also, we have arithmetic instructions, logical instructions, branch instructions, subroutine instructions, and bit manipulation instructions in 8051. In this video, we are studying about the logical instructions in the 8051 microcontroller. So these logical instructions, they perform the operation like logical AND, logical OR, logical NOT, logical exclusive OR. So all these logical operations, they are performed by the logical instructions. The first instruction which come under this category is logical AND. Now this instruction, it performs the logical AND operation with two 8-bit numbers. We have the two 8-bit numbers. One is stored at the source location and one number is stored at the destination location. For this logical AND instruction, we have the mnemonic, that is the code in 8051 as ANL. Okay, this is the mnemonic, and format is, first we are going to write the destination location, then we will write the source location. So in destination we will have an 8-bit number, in source also we are going to have an 8-bit numbers. So these two 8-bit numbers, they are going to ANDed up every bit, like destination will also have the 8 bits and source will also have 8 bits. So D0 bit of both source and destination, they will be ANDed up, then D1, D2, D3, D4, D5, D6 and D7. So every bit of source and destination, they will be ANDed up. Okay, and the results will be stored in the destination. So destination is going to store the result, and the value which is there in the source, that is not going to be affected. So source and destination, they are ANDed, result is stored in destination, source contents are not affected. And after this AND operation, obviously if any of the flag is affected, like carry flag, no carry will be generated in this case. Suppose like 0 flag is there, okay. So after the AND operation, if we are getting the result as 0, so 0 flag will be affected. Okay, so if we talk about the examples of this instruction, we will have ANL, accumulator, and directly we are specifying the 8-bit immediate data in the instruction itself. For immediate data, we will use this hashtag sign. Okay, so here we will have that 8-bit data, and the contents of the accumulator, they are ANDed up, and the result is stored in the accumulator itself, because accumulator is here as the destination. Next example we have is ANL, and we are directly writing the address of the memory location. Okay, like 57H if we are writing, then that memory location, the contents of that memory location will be ANDed with the accumulator. Also we can have register, any of the registers, 8 registers of the register banks, that is R0 to R7 of the 4 banks, are from bank 0 to bank 3 of the 8051 we can use here. So any of the registers can be there, direct address is there, indirect addressing also we can have. like R0 and R1 register can be there. Indirectly the address of the memory location which is having the data that is given in the register. Okay, also the destination, it can be the direct memory location and the accumulator. It is not necessary that destination is always the accumulator. Memory address can also be there. Also memory location, and directly we are writing the immediate data. Okay, so these are the examples of the logical and operation. We are using the instruction ANL for this, and destination and source are the operands for this instruction. Next instruction we have is the logical OR. For logical OR, we have the mnemonic as ORL. Just like for logical AND, we are having ANL. For OR, we are having ORL, destination and the source. Again, destination and source will contain the 8-bit data. Bitwise, the digits are logically odd with each other. Destination will have the 8 bits, source will have the 8 bits. So all the 8 bits, they are individually logically odd with each other, and result is stored in the destination, and source will the contents of the source, they will not be modified. Okay, examples of logical OR are ORL. Again, we have the immediate data, or we can have a register, or we can have a direct memory address, or we can use indirect addressing also. Okay, in this case the destination is the accumulator. We can have examples where the destination is the direct memory location and we are having a data here. Also we can have source as the accumulator. So here direct is representing the address of the memory locations like 45, 57, any of the direct addresses given in the instruction. Okay, so these are the examples of logical OR instruction. Next we have logical exclusive OR. For this instruction we have the mnemonic as XRL. Okay, again then we have the destination and the source. Again bitwise the contents of destination and source, they are exclusively odd with each other and the result is stored in destination. Here also we have the same things like OR and the AND instructions. XRL, A is there, we can have the data, we can have a register, we can have direct memory location, we can have indirect addressing also. We can have destination as direct memory location and data, and also exclusively or the direct and the accumulator. Okay, so this instruction, it is going to logically exclusively or the contents, the individual bits of the destination and the source. In the case of exclusive or, we know that when the two bits, they are different from each other, like 0 1 or 1 0, then only the output is high. Otherwise when it is 0 0 or 1 1, the output will be low, that is 0. So this was logical exclusive OR instruction. Next instruction we have in this category is logical NOT instruction. The logical NOT instruction, it complements the operand, means whatever is the situation like if it is having 0, then the bit is reversed, means it becomes 1, and if the operand is having 1 as the bit, so it will be reversed, it will become 0. So this logical NOT operation, this instruction, it complements the operand. In this category logical NOT, we have the instruction CPL. Okay, so CPL, this instruction, it complements the operand. And the result is stored in the operand itself. Complements means that if the bit is 0, it will become 1, and if it is 1, it will become 0. So this is just like a logical NOT operation. Okay. Examples of this instruction, if we write here, then CPL A, CPL C, or CPL, then the bit address. In 8051 microcontroller, there are some addresses which are bit addressable also. So here we will write the bit address. Okay, address directly, the address of the memory location can be written, and the contents of that memory location, they will be reversed. CPLC means it is going to complement the carry flag. CPLA means it is going to complement the accumulator, and the result of this operation CPL, after complementing or after reversing the bit, the result is stored in the operand itself, that is in the accumulator or the carry and the bit address itself. Okay, so this is the logical NOT instruction. Next instruction we have is swap A. Swap means you have to exchange. Okay, so accumulator, it is an 8-bit register. So this 8-bit register, it is having, it can be divided into 4 bits. Okay, two parts it can be divided. The upper 4 bits, because a collection of 4 bits is called a nibble, so upper 4 bits are called upper nibble and lower 4 bits are called the lower nibble. So this instruction swap A, it is going to exchange the nibbles, means lower nibble is going to become the upper nibble and upper nibble is going to become the lower nibble. So suppose accumulator, it is having the number 45. So now after this instruction, the new number will be 54. Okay, means upper and lower nibble, they are exchanged. Okay, so this is also a logical instructions. In logical instructions, the rotate instructions also come under this category. So now we will study some rotate instructions in the 8051 microcontroller. As the word rotate says, means the contents of the operand, they are rotated. Okay, either they will be rotated from left to right or from right to left. So depending upon the rotation direction, we have 4 types of rotation. Okay, first instruction is RRA, that is rotate accumulator right. Now accumulator, we know that it is an 8-bit register, so its 8 bits are like D7, D6, D5. These are the 8 bits of the accumulator. Now we have to rotate the accumulator to the right side. Okay, so this D0 bit, it will now become the D7 bit. D7 will become D6, D6, D5, D5 to D4. D4 is shifted to D3. D3 bit will now become D2. In this way, all the bits are shifted. So D0 bit, it is the least significant bit and D7 is the most significant bit. So when the accumulator is rotated to the right side, the LSB, that is D0 bit, it now becomes the D7 bit. Okay, and all the bits, they are shifted to one position to the right hand side. So this is the instruction, rotate accumulator right. Next instruction we have is rotate accumulator to the left hand side. RLA, that is rotate accumulator. Again, accumulator is an 8-bit register. Now this time shifting has to be done to the left hand side. So D7 bit, it will now become the D0 bit. Okay. D6 is shifted to D7. In this way, shifting is done. Every bit is shifted to the left hand side by 1 bit position, and the most significant bit now becomes the least significant bit. That is D7 now becomes the D0. So this is the instruction, rotate accumulator left. In these two instructions, the operand, it is always the accumulator. So whatever content we want to move, we have to first, we want to rotate, we have to first store it into the accumulator, and then accumulator is rotated to the right hand side and the left hand side. Next instruction we have is RRCA. That is rotate accumulator right through carry. C stands for the carry. So this instruction becomes rotate accumulator through carry. Okay, so here along with the contents of the accumulator, we will use the carry flag. Accumulator has to be rotated to the right hand side. Okay, so this D0 bit, it now goes to the carry flag. Carry flag will go to the D7 bit. D7 will go to D6. In this way, all the bits are shifted to the right hand side by 1 bit position. Earlier when we studied the rotate accumulator right, the D0 bit was going to the D7 bit. But now we are rotating it through the carry flag. So D0 will go into the carry flag and carry flag will become the most significant bit. Suppose carry flag is 0, so 0 will become the MSB. Suppose carry flag is 1, so it will become the MSB. Okay, and whatever is the D0, suppose it is 0, so carry flag will become 0, means it is going to reset. If D0 bit is 1, it is going to shift into the carry flag and carry flag will be set. Okay, so here rotation is done but through the carry flag. Okay. Next instruction we have is rotate accumulator to the left hand side through the carry flag. So RLCA, C is for the carry, L is for left, R for rotate and A is for accumulator. So rotate accumulator left through carry. Okay, so rotation again accumulator and 8-bit register. We have the carry flag here. Now shifting is towards the rotation is done through the left hand side. Okay, so most significant bit it will go to the carry flag, and carry flag will go to the least significant bit D0. D0 is shifted to D1, D1, D2. In this way, every bit is shifted to the left hand side by one bit position, and the MSB it goes into the carry flag, and carry flag goes into the least significant bit. Okay, so in this way all the bits are shifted to the left hand side, and the carry flag is also considered with it. So this is the rotation of the accumulator to the left hand side through the carry flag. So these are the 4 rotate instructions in the 8051 microcontroller. So in this video, we studied about the logical instructions, in which comes the logical AND, logical OR, logical exclusive OR, logical NOT operation, and then the rotate instructions, that is rotate through the right, rotate to the left hand side, rotate through carry, and rotate left through the carry. Okay, so these are all the logical instructions in 8051 microcontroller. So I hope that this topic is clear to you. Thank you.